Hello, boys and girls. Sorry I could not be with you today. I have a little bit of training to do over at Centennial. I will be back tomorrow. In the meantime, what we're going to work on today is taking a look at slope and these linear expressions in three different ways. We can represent this data when we look at a line graphically. We can also represent this data algebraically in an equation, as well as we can just look at the pure data of it, our x and y values in a data table. Now, we've done this before, but what we're going to do today is we're going to look at all three of these representations together, and I hope that the connections will be made today and you'll have a stronger, better understanding of how this all fits together. Let's look at our worksheet, and we're going to work through, I believe, 8 problems together. And please do the homework assignment that the substitute gives you. I'll see you tomorrow. Okay, boys and girls, let's take a look at what they've given us here. We have 3 columns. We have a column to put our algebraic equation in of the line. We have the middle column to actually graph our line. And the third column has our table of data in it. And they gave us their table of data. And what I'm going to do is use this to graph my line, and then I'll come up with my equation. That's one order that we could go through. Okay, let's see. I'm going to start with those coordinates right there. My x is a -3, so I'm going over here, and then my y is a -9, which is all the way down here. So that will be my first point. Then I'm going to pick my y-intercept, which is right here. My x is 0, and my y value is -3, which would fall right there on the y-axis. And then I'll also take my last piece of data. So I have 3 points, and I can connect that to make my line. My last set of coordinates that I'm going to use from the table here is 3, 3, which is 3 to the right, and 3 up, which would be right there. I'm going to grab my line tool and see if I can line things up. If I go from there to there, and I can actually keep on going. There's my line, approximately. Okay, and to find our algebraic equation of this line, you got to remember we want to put it in the slope-intercept form, which is y is equal to mx plus b. We want to ask ourselves what is our slope, m, and what will be our b, which is our y-intercept. Our b or y-intercept is right here, which is -3. And our slope is our rise over run. When I go from a -9 to a -3, there is a change of 6. So I'm going up 6, and then I would go to the right 3, okay, because I'm going from -3 to 0. So I'm going up 6 over 3. So my slope, my rise is 6, my run is 3, which is the equivalent of 2. 6 divided by 3 is 2. Now when I put this in my slope-intercept form, I have y is equal to 2x minus 3. So there's my equation, my line, and the data table they gave to me. Let's take a look at the next piece of data they gave us. They gave us a line here, and they want us to graph it. Well, I'm going to pick some key points here. I'm going to start out with my y-intercept, which is easy to find. That would mean my x is 0. My next point looks like it is right about there, and that's a good point to pick, which, oh, by the way, that would be 5. Okay, my y-intercept is 0 and then 5 up. My next point of intersection, I think, is easy to pick, is this point right here, which is x is 4 to the right, and it looks like it is 7 up. And then my last point of intersection, I would say it's over here, I'm going to use, which is,
it's 10 o'clock.
My x-coordinate would be 8, and my y-coordinate is 9. I'm all the way up at 9 over here. Okay, so I have my table. If I want to find, again, if I want to find my equation, I'm going to use y is equal to mx plus b. That's my template. That's my guide to guide me. I need to find my slope and my y-intercept, which is b. My y-intercept is is going to be 5. Okay, this line intersects the y-axis at 5. So there's my b. And my slope, if I go from this point, I go up. Looks like I'm going up. 1, 2. Okay, so I'm going up 2. And then I am going over 4. 1, 2, 3, 4. So my rise is 2, my run is 4, and I can reduce that to 1/2. So my slope is 1 over 2. And now I go to use my slope-intercept form. Y is equal to my slope, or m, which is 1/2, times x, plus my y-intercept, or b, which is 5. And there is my equation. Let's look at our next two problems. Here I have the only piece of information they gave us was the equation y is equal to a negative 3x plus 1. So here, here's my slope, because I know that y is equal to mx plus b, and m is my slope, and b is my y-intercept. So I'm going to start with this. My y-intercept is really my starting point for graphing a line. So my starting point is at 1 right here. That's my first point. And then my slope is a negative 3, which means negative 3 over 1, which means 3 down and 1 to the right from my starting point. So I'm going to go down 3 and then 1 to the right, which is right there. Then I go from that point, go down 3, which would take me to negative 5, and 1 to the right, which would take me to 2. And there's my points. In fact, I can graph them. So when x is 0, y is going to be 1. When x is 1, y is going to be a negative 2. When x is 2, y is going to be a negative 5. Okay, and there's my data. And then my line would look like this. There we go. Okay, and we can see that I have a downward or negative slope. So they gave the equation. I used the equation for my starting point, my y-intercept, used my slope to find each point, just kept going down 1 to the right, sorry, down 3, 1 to the right, down 3, 1 to the right, and then that also gives me the data to put in my table. Our next problem, they start off with the data table. I'm going to take 3 pieces of this data, 3 sets of coordinates, and use that to graph my line. When x is a negative 3, right here I have to go down 3. That's my first point. And then let's pick this one here. That's my y-intercept is at 0. And then when x is 3, y is 3, which I can tell right now my slope is 1. I have a nice 45-degree angle. I connect these lines, and there you have it. Got the classic 45-degree angle, which is a slope of 1. So y is equal to mx plus b. My slope is 1 over 1. And my y-intercept is at 0 right here. And that would look like y is equal to 1x, or x, plus 0, which, that's it. Okay? Where's my m? Well, my m is 1. I don't need to put 1x. When I got x, I got 1x. And then my b is 0. I really don't need to put plus 0. I just leave it out. And there you have it. Let's look at two more problems. This problem, they start out with an equation. This time, though, the equation is not written in the slope-intercept form, which is y is equal to mx plus b. It's out of order. So I need to put it in order. The first thing I need to do is, if I want to isolate or solve for y, I need to get rid of the x. I'm going to subtract x from that side of the equation. What I do to one side, I must do to the other to keep it balanced. Okay, and the x's cancel each other out over here, and I bring down my y, and I got y is equal to a negative x plus 3. Now, I bumped this around. Somebody said, well, Mr. Yerk, shouldn't it be 3 minus x? Yeah, but minus x is the same thing as negative x, and 3 is the same thing as plus 3. So I just flip them around so that it's in the slope-intercept form. This would mean then that my slope is a negative 1, and my y-intercept is at 3. Now I can begin to graph. So when x is 0, y would be 3. So that's my starting point. Oh, and by the way, let's get the equation here. So my slope is negative 1, which means I go down 1 to the right, go down 1 to the right, because my rise over run is negative 1 over 1, and so forth, down 1 to the right. Let me connect these lines like so. Okay, get the idea, and we have a downward slope. We can continue. Okay, when x is 1, y is going to be 2, and when x is 2, y is going to be 1. Okay, and we see a very interesting correlation. But there we have our data table. Here we have our equation of a slope of negative 1. When x increases, y decreases by 1. X increases by 1. Y decreases by 1. It's a negative slope, and that's what it looks like. And our next expression, they gave it as a line, and our y-axis is going to be 0, 0. And let's see if we can find another point. Take over here to 4. It looks like when x is 4, y is a negative 2. And when x is 8, looks like y is a negative 4. Okay, so let's see if we can make heads or tails of this line. My slope looks like from here to here I'm going down 2, and then I go 4 to the right, down 2, 4 to the right. So my slope, my m, is a rise of negative 2, and my run is 4, which I can reduce that to a negative 1/2, and my y-intercept is right here, which is 0. What will that look like in equation? Y is equal to my slope, which is a negative 1/2 x, plus 0, which means I don't need to put a b there. I don't need to put my y-intercept, it's just 0. As always, boys and girls, I hope that was helpful. If you have any questions, please bring them to class tomorrow. I'll be back. And don't forget to do your homework tonight. I'll see you then. Bye-bye.